would like to read at the top of page 56? Talking about the midpoint of a line segment. Okay, thank you, Alan.
Coordinates on a Cartesian grid are a simple and convenient way to specify a location. Such grids have many uses beyond graphs and maps. Machinists use coordinates to direct computer numerical control machine tools that shape, drill, and weld parts. Similarly, coordinate systems are essential for programming industrial robots on automated assembly lines. When you know the coordinates of a set of points, you can calculate the coordinates of related points, such as the midpoint between a pair of points.
Good, so we're looking at midpoint of a line segment. Okay, the two definitions that we need to know, and are pretty basic, we've known them for a long time. The first one is the Cartesian grid. It's just defined as a grid with perpendicular axis. Axis is, and it looks like this, right? We have X always on the bottom and Y on the top. So that's our standard Cartesian grid. And then we have the other definition, and we'll be talking about mostly today, is the midpoint. That's the point that divides a line into two equal parts. Okay, I'm going to move to page 60. We're going to look at example 1 on page 60. And I'll have Julian read on page 60 at the bottom.
Example 1, find the midpoint. A city has two hospitals, shown on the city map at the coordinates A, 35, and B, 11, 14. The city wants to build a new ambulance station halfway between two hospitals. Determine the coordinates of this location.
Okay, so there's two ways that we're shown how to do this. The first one is to calculate the rise and run, the slope, and then to divide those by 2 and add it to the initial starting values. That way I think is a little more complicated than it needs to be. There is also the second method, which is to use a formula. All right, the formula for midpoint, this is one you're going to want to memorize, is x, y, so that's the point. It's just x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so this is pretty easy to memorize. You're just adding the x coordinates, dividing by 2, and adding the y coordinates and dividing by 2. All right, so then if we have 2 points now in this question, we have point A, which is 3, 5, and point B, which is 11, 14. We're just going to sub that into our midpoint formula. This is our midpoint. Okay, so you can see that I've subbed in x1 and x2 into the first point formula, and y1 and y2 into the second point, divided each by 2, and I have my midpoint. Any questions there? Yep.
What happens if they give you the midpoint and don't you have to go backwards?
Oh, we'll get to that question. Okay? You can work backwards, but I'll show you that in a bit. All right, so that's example 1. We're going to look at example 2, which talks about the median. So first, let's just define median. Median is defined as, say, line joining okay, it's a line joining the vertex of a triangle to the midpoint of the opposite side. Who knows what a vertex is? Just one person? Just Gianluca? Connor? Hey, Connor, tell us, what's a vertex? Yeah, it's just a corner. Exactly right. So basically, any kind of point of the 3 on a triangle. Okay, so this is vertex B, this is vertex A, and this is vertex C. Right, so if we wanted to draw a median, we'd have to draw a line joining the vertex, so let's say vertex B, to the midpoint of the opposite side. So that would be the vertex, where these two sides are the same. Okay, so this is the median. This is the vertex. And these are equal sides. Any questions there? All right. So example 2 says, determine an equation for the median from vertex C for the triangle with vertices C, A, and B. And it gives us the coordinate points of each one of those points. So we're going to roughly draw this triangle. Okay, so we have our vertex A, B, and C. And it says to determine an equation for vertex C. So if I wanted to draw vertex C, Matthew, how would I draw that? The back, Matthew. Corner.
Like redraw it, or?
Like, how would I draw median C? Just going to come from this vertex down to the opposite side, right, and split this line in two. Okay? See that? So a median is just dropping down from the vertex to the opposite side, where the opposite side is divided into two equal line segments. So the first thing we want to do is, we know that the median divides this line into two equal line segments. We also know that the midpoint divides this line into two equal line segments, okay, by definition. So Kyle, how can we find out the midpoint of this line, AB? Any idea? I want to find out this midpoint. Let's say my graph is not very accurate, which it's not. So I'm not going to rely on the graph. I want to use algebra to find out this midpoint. Right, you're going to use this formula right here. Excellent. So we'll use this formula for A and B, okay? Because that'll give us the midpoint that this vertex needs to come down, this median needs to come down and hit that point. Okay, so then our formula for midpoint, right, this is our mid That's our formula, okay? It doesn't change, it stays the same. Important to memorize it. Now we're just going to plug in these 2 point values. So negative 3 plus negative 2, sorry, plus positive 2. And y1 is 3 plus negative 5 over 2. Does it matter which one I call y1 and which one I call x2? Yeah? No, it doesn't matter, okay? Because we're adding, it doesn't matter if I add negative 3 plus 2 or 2 plus negative 3. As long as I'm consistent. Okay, as long as I'm consistent with my x and y's, if I want to call this x1, I have to call this y1. If I want to call that x2, that has to be y2. Okay, but it doesn't matter which one I call. So now I'm going to do this. Negative 3 plus 2 is negative 1/2. 3 plus negative 5 is negative 2 over positive 2. So we're left with negative 1/2 over negative 1. Okay, so that's our midpoint now of that triangle, or from vertex C. That's our midpoint of AB. Okay, next we want to do, if we want to find an equation for this line. So I have 1 point on the line. What else do I need? If I have a point on the line, to get the equation, I need something else about that line. What else do I need, Alan? Good. Okay, I have another point. Great. If I have 2 points of a line, then I can figure out the equation of the line. How do I do that? For the equation of the line, I need 2 things, right? I need my b value, which is the y-intercept, and I also need, Steven? Equation of a line, y equals mx plus b.
Y-intercept.
Yeah, that's the b value, and I also need the
Slope.
Good. So I have 2 points on the line. Can I figure out the slope?
Yeah.
How do I do that?
X1 minus. Yeah, X1 minus X2 over Y1 minus X2.
Other way around.
There.
It's rise overrun, right? So y2 minus y1 over x2 minus x1, right? Okay? So my midpoint is there. I found it over here. So now I have 2 points. So it just goes into one of those questions where we have 2 points on a line, how to find the equation. So the first thing we want to do is find the slope. So my slope is going to be y2 minus y1 over x2 minus x1. So I'm going to say y2 is 2 minus 1 over negative 1/2, 5 minus 1/2. So we have 3 over 5.5, which is equal to 3 over 11 over 2. And then when I divide by a fraction, I multiply by the reciprocal. So this is 3 times 2 over 11, which is 6 over 11. Any questions there? Steven?
If we already got a decimal, would we have to convert it into a fraction?
Yes. Yeah, I want you to work with fractions, okay? Because decimals just aren't as accurate. They're not exact numbers. Okay, and if we can avoid rounding, we should. Okay, so this is our slope. M is equal to 6 over 11. So if that's my slope and I know my equation is y equals mx plus b, I can plug this into my formula. So y is equal to 6, 11x plus b. And now how can I find out my value of b? Ace. How do I find this out now? I have the slope, but I still need to find b. We did it over, I think, in the previous example. So, Ace, if we have the slope of a line, and we also have a point on that line, what can I do to find out b? Remember? I think Kyle's going to help you out.
You can substitute the y for the y point on the.
Right, so what I can do then, Ace, is I can just substitute this x and y value into the equation, okay, and solve for b. Alright? So I'm going to use this point as opposed to this point just because it doesn't involve fractions and negative signs. So I'm going to then say my y value is 2, 6 over 11 times x is 5 plus b. Okay, now I solve for b. So I have 2 is equal to 30 over 11 plus b. b is going to equal 2 minus 30 over 11. I need to find common denominator here. So 2 is just the same thing as 2 over 1. So I got to multiply by 11. So I have 22 minus 30 over 11 is equal to b minus 8 over 11 is equal to b. Okay, so then my formula then becomes, plug this in, sorry, my equation of my line then becomes y is equal to 6 over 11x minus 8 over 11. Any questions there? Okay, so rather long question, but I think it's fairly straightforward. Matthew?
Couldn't you also have found the midpoint between -1/2 and -1 and 5 and 2?
Found the midpoint between these 2
Yes.
points? Okay, for what reason?
In order to find the median.
This point?
Yeah.
I'm not sure how would that give you the equation of this line?
Oh, okay. I thought you were looking for the median.
No, the median's here. We found it. The median is actually this line. That's what it's called. So this whole line is called the median. Yeah, so don't get confused by this. The median is not the midpoint between this. The median is actually this whole line. Okay, that's what we call it. The line that drops down from the vertex. Okay, the last problem I want to look at is the equation of a right bisector. This is example 3. I have somebody read on the bottom of page 63. Stephen?
2 schools are located at the points P -1, 4 and Q 7, -2. On a town map, the school board is planning a new sports complex to be used by both schools. The board wants to find a location equidistant from the two schools. Use an equation to represent the possible locations for the sports complex.
Okay, who can tell me what equidistance means? Just Alan? Matthew at the back? Okay, Alan, what is it?
Equally distant.
Good, yeah, just like it sounds, right? Equally distant, so the same distance away. All right, so we have 2 points here. We have P and Q. So again, I'm going to draw this triangle very, very rough. And of course, you want to draw this more accurately in your notebook. Here's my x-axis, here's my y. So these are our 2 schools, P and Q. So we want a point here, so really what we're looking for is a point that's equal distance from these 2 schools. So right here, this is our unknown point. And the way we can determine that is we find the midpoint between P and Q, which is going to be right here. Okay, somewhere in the middle, well, exactly in the middle between these 2. And then we find the right bisector, it's called. Okay, and what the right bisector is, that's this line here. So we're going to define this. Right bisector. It's the line Okay, so it's the line that passes through the midpoint of a line segment and intersects it at 90-degree angle. So there's two kind of constraints on the right bisector. Or two properties that it needs to be defined by. The first is that it has to pass through the exact middle of the line segment that it's bisecting. That's why it's called a bisector, because it crosses through the middle of the two. Yep.
So it's like the bisector, the same thing as the median,
The bisector is not the same as the median, no, because the median is tied specifically to the vertex. Okay, so it's talking about a triangle and it's specifically coming down from a particular vertex. Okay, so it's not just a bisector. A bisector could be any line that separates it into two equal parts. So it's not the same as median. A right bisector divides a line into two equal line segments, but it also has a 90-degree angle with the line that it's dividing. Okay, does that make sense? So it's cutting that line right in half at a 90-degree angle. Okay, important that you guys understand the definition of this. You're going to see this quite often. Okay, and it helps us with these problems where we're looking for equidistance, because then we can create this triangle where we know this midpoint is the exact same distance from this point as it is from here. And then if we go at 90 degrees, that will create every point on this line an equal distance from these 2 points, Q and P. Okay, does that make sense? So as I'm going up, these lines are equal distance away. So the first thing we want to do then is to find out the slope of this line. If we know it's perpendicular to this line, if I can find the slope of the PQ line, I can then find the slope of my right bisector. Does that make sense, Matthew?
So that triangle, you mean isosceles triangle?
This triangle would be, yes. Yeah. Yeah, these two lengths are going to be the same. Good. But it's important to recognize what is the slope of this line in comparison to this slope. Who knows that? So when two lines intersect at 90 degrees, their slopes are? Yeah?
Negative reciprocal.
Good, negative reciprocals. That's very important to know. You have to have that memorized, right? If the two lines are bisected at 90 degrees, their slopes are negative reciprocals. So I'm going to find the slope of PQ, and then I'll know the slope of this right bisector. All right, so let's find the slope of PQ. So slope PQ is going to be so our slope of PQ is negative 3/4. So therefore, our slope of right bisector is going to be equal to positive 4/3. So this is the negative reciprocal. All right, we can also write that M, make a parallel line is 4/3. Next, we want to find out the point, because if we're looking for the equation of this right bisector, we need to know the slope and we need to know a point on that line. If we have a slope and a point on the line, we can get the equation of the line. So to find the midpoint of these two, again, PQ, we can use the formula for midpoint. So the midpoint of PQ is going to be equal to xy, which is x1 plus x2 over 2, y1 plus y2 over 2. x over 2 and 2 over 2. So our midpoint is 3, 1. Now I have a point on the line. I also have the slope. I can now calculate my formula for that line because I know my equation of a line looks like this. Sub in my slope, which is 4/3. And now sub in my point into here. And solve for b. So now my formula for the line becomes 4/3 x minus 3. Any questions there? Okay, so right bisector is actually a little bit easier than finding the median because it tells us two things. This line tells us two things about this line. It tells us the slope, and it also tells us a point on the line. The slope being the negative reciprocal, and the point being the midpoint between these 2 points. Any questions? Okay, we'll stop there. You guys have your daily plan 2.1 as well as the getting started.